This is R.D. Sharma Solution, Class 12, Chapter 14, Differentials, Errors and Approximation Exercises 14.1. In order to use the differentials for errors and approximation, there are certain things we need to understand. The first thing is dy by dx that we have been talking about is the differentiation. And this is just a symbol. It is not we are dividing dy by dx. These are now two separate entities. They are single. dy by dx is just a symbolic way to represent. And how did we get this? When we said delta y by delta x, that is change in y, y2 minus y1, and change in x, that is x2 minus x1. So when you make a graph like this, and one point is x1 y1, the other point is your x2 y2. So the slope, that is y2 minus y1 divided by x2 minus x1, that is the change in y divided by the change in x, the change is called delta. What was the change? So when delta x tends to 0, this becomes delta y by delta x becomes dy by dx. So when dy is assumed or considered as a different entity and dx is considered as a different entity, then how are we going to use it for the errors and approximation? For example, we have a function y equals fx. Y equals to fx is a function, normal function. Now, delta x is the change in x. So, in order to find out the corresponding change in y, that is delta x is x2 minus x1. And the difference is very, very small. That is the change in x is very, very small. So, what will be the change in corresponding y? So, that delta y will be y2 minus y1, right? So delta y by delta x, when the delta x is very, very less, that is limit delta x tends to 0. The change in delta x is quite small. Then we call it as dy by dx, and that we were saying it as f dash x or y prime or y double prime. That is the differentiation. Alright. Now this f dash x, when we have a relationship like this, delta y delta x, dy dx and f dash x. So delta y by delta x is nothing but f dash x, and when it is dy by dx, then there is a change. So whenever we write delta y by delta x, we have to add a very small element, very minute, which is very so less that it tends to 0. Alright, delta x tends to 0. That is why we were saying that the change can be written as dy by dx. So when we are talking about delta y by delta x, when you want to say it as f dash x or differentiation, then you have to add a very small element, that is this epsilon. This epsilon is so small that it is tending to 0. So now we can write it as delta y. I am multiplying delta x cross multiplying on the right hand side. So f dash x into delta x into epsilon into delta x. Epsilon is a very small like 0. So this epsilon is so 0 that this can be disregarded or it can be eliminated or ignored. So delta y becomes equals to f dash x into delta x. But as our discussion started, I told you that dy by dx is nothing but f dash x. So in place of f dash x, we can write it as delta y is equal to f dash x into delta x. In place of f dash x, you can write dy by dx. So this is the whole scenario. That is, if you know the change in x, then there is a change in y, and that change in y is delta y. And that can be computed by dy by dx. Alright. This is the whole scenario of errors and approximation. Now there are certain terms. That is very small change. We call it as absolute error. So delta x, very small change, absolute error. Alright. So for x, delta x is an absolute error. Then comes the relative error. So delta x, again a change. For x, when we divide this with the actual x, we call it as a relative error. There is one more term, that is percentage error. This percentage error is nothing but when we are talking about the change in x. For x, delta x by x was a relative error. When you multiply it by 100, this becomes the percentage error. So how are we going to solve? There has to be some algorithm. So that algorithm we are going to see whenever we have some independent variable, that is the value which you give and it is independent of any other thing, like y equals to fx is the function. X, for every x value, there will be corresponding y value. So x is a independent value, y is a dependent value. So for every x, the first step for the initial value when we start, this x, we start with x and we say that there is a change. What is the change? Delta x. So this x plus delta x, because the change is delta x, so x plus delta x is the actual change. For example, there is an object and when you heat it up, it will expand. So there will be a slight expansion, that is delta x. So final will be what? X plus delta x. That is the size of after heating will be x plus delta x. So in order to get this delta x, because ultimately we have to find delta y. So this delta x has to be assumed equal to dx. Alright. Dx and delta x has to be assumed equal. Now dy by dx has to be computed. You already have a function y equals fx. Now you have to differentiate. So y equals to fx is there. First you find out the differential. For example, y is equal to x square. The differentiation will be 2x. That is the third step. Now the fourth step is what? Because dy by dx has already been computed. But if we are finding things at x and y, so we'll find the dy by dx at x equal to whatever the value means we'll find out the value at x which is given in the question. The next thing will be, because we have to find out delta y, right? So for that we'll take dy and we'll again make it equivalent to delta y. So dy by dx can be written as dy by dx is equal to dy by dx. But as we have assumed dy as delta y, dx as delta x, so now you can write this as delta y is equivalent to delta d is dy and the change in y, that is the delta y, because started with change in x, tried to find delta y. So delta y will be equal to dy by dx into delta x. Because in this error and approximation, we have assumed that delta x is equal to dx and delta y is equal to dy. Alright. So this is the question where we will prove this algorithm also. We have a function y equals to x square. If x is equal to 10, delta x is equal to 0.1. Find delta y. So if you understand this very well, you will be able to solve all the questions because they come in your examination. This is a very important topic. So y is equal to x square is the function. The change in x is 0.1. So x2 minus x1 is 0.1. So delta x is what? 0.1. And it is also given at x equals to 10. X starting value of x is 10. The change is 0.1. And then we have to find out dy by dx. So we already have a function x square. When we find out the dy by dx, it is 2x. Now we have to find out dy by dx at initial value of x. What is the initial value of x? It is 10. So as I said, you have to find this dy by dx at x equal to 10 or the value which is given as x. So we will find out dy by dx as at x equals to 10. So it will be 2 into 10. 2 into x, that is 2 into 10. It is 20. So we have found out dy by dx 20. And we know the procedure delta y will be equal to dy by dx into delta x. So now we have the value of dy by dx. We have the value of delta x. Just put in here in order to find out the corresponding change in y, which is delta y. So delta y is going to be dy by dx was 20. Delta x is already given in the question 0.1. So this is going to be 2. So this is how, if the change in x is given, the change in y can be found out using the function using our differentials. This is the errors and approximation. If y is equal to sin x and x changes from pi by 2 to 22 by 14, what is the approximate change in y? So we have x initial value is pi by 2. Alright. Then we have the change. So when it changes. When you add delta x with x, it becomes 22 by 40. So x plus delta x is 22 by 40. No problem. So what is dx? We have assumed it to be equal to delta x for errors and approximation. Basically, delta y by delta x is nothing but dy by dx when delta x tends to 0. When delta x tends to 0, we already regarded it as dy by dx. So dx is delta x in this case. So dx is delta x. What is delta x from here? You can take x on the right hand side. It is already given, it is pi by 2. So delta x is 22 by 14 minus x. So delta x is 22 by 14 minus, what is x? It is initially pi by 2. So 22 by 14 minus pi by 2. Pi is nothing but 22 by 7. So it is 22 by 7 and 7. There is a 2 in the denominator also. So it is 22 by 14. So 22 by 14 minus 22 by 14. It is 0. So delta x is equal to 0. Delta x is 0. Now let us come to the function y is equal to sin x. So first we have to do the differentiation, that is dy by dx. The differentiate sin x is cos x. Now we have to find out the value of dy by dx at initial value of x. What is the initial value of x? Pi by 2. So cos pi by 2 you have to find out. What is cos pi by 2? Cos 90 degree is 0. So it is 0. And now coming to the final conclusion, delta y is dy by dx into delta x. From here you can find out that also. So it is dy by dx into delta x. Dy by dx at x equals to pi by 2 is 0. Delta x is 0. 0 into 0 is 0. So delta y is 0. So there is no change in the value of y. So you can write it like this also. The radius of a sphere shrinks from 10 to 9.8. So it is coming down. Find approximately the decrease in its volume. Decrease in its volume. So first thing you need to know what is the volume of the sphere, the surface area of the sphere, all these things you need to know. Volume is 4 by 3 pi r. The surface area is 4 pi r square. Whenever it will be used, it is not in this question, but maybe when it will be used in the later questions. So radius is decreasing. The initial is 10. When you add delta x, it will be 9.8. You can start with x, you can call it as r, it's up to you. Okay, I'll start with x and I'll later change it into r. X is 10, x plus delta x is what? 9.8. So delta x will be what? X and r, I'll change and use as the same way. So delta x can be computed as 9.8 minus 10. But you don't have to use a negative one. Please assume, because the question is asking approximately the decrease in volume. So we know we are talking about decrement. So we don't have to use negative because we're calling it as shrink. We are calling it as decrease. We don't have to use a negative sign. So this don't have to write this negative. Okay. So delta x is now computed. What about volume? You have to differentiate it. 4 by 3 pi r cube, just differentiate it. dv by dr is going to be equal to, you can call it as dx also. It's up to you. So dv by dr, it will make it easier. dv by dr is going to be equal to 4 by 3 pi r cube will be 3r square. 3 cancel, 4 pi r square. So dv by dr at r equals to initial value, that is 10. You have to compute 4 into pi into, this is 10. So 10 square, 400 into pi centimeter, because it is volume divided by r, so it will be centimeter square only. Next thing will be, in order to find out delta y, we have to use dy by dx into delta x. So just use this. So in order to find out delta y, this is here, we in this case delta y is dv, delta x is dr, same thing. So dv by dr we have computed, it is 400 pi, and delta r also we have computed, it is 0.2, and when you multiply, this is going to be 80 pi centimeter cube. A circular metal plate expands under heating so that its radius increase by k%. So this is a circular plate and this is increasing k%. Find the approximate increase in the area of the plate if the radius of the plate before heating is 10 cm. So now you know the concept. Here we are introducing a new concept, which is the relative error. So x was initially x, then something was added, delta x was added, and the final value will be x plus delta x. But this x is radius. We have started with x is equals to radius in this question, and we are talking about increase in the area. So y, assume it to be area. Y is area, x is radius. So what is the relationship? The circular metal plate expands under heating so that its radius increases by k%. Now we have to introduce a concept that we have discussed already. That is the error, prediction of error. Area is already pi r square, and since we have assumed a radius as x, you can call it as pi x square. So area is directly proportional to radius of square of radius. So as radius will increase, the area will increase. So y, you have this, y equals pi x square, call it as x square. Now there is an increase by k%, and I told you that the percentage error is nothing but delta x by x into 100, or in this case delta r by r into 100, same thing. So delta x by x into 100 is given in this question as k%, so just call it as k. Alright, so if radius is 10 centimeter, what will be delta x? X is 10. So multiply this k into 10 divided by 100. So it will be 0, 0, you can cancel, k by 10. So this is your delta x. And this y is pi x squared. So first we have to find out dy by dx. So dy by dx is pi, and I'm differentiating this one. Pi into x square will be 2x. So 2 pi x it will dy by dx. Now we have to find out the value of dy by dx at x equals to 10, which is given in the question. So x equals to 10 is 2 into pi into 10, that is 20 pi. How about delta y? Delta y is dy by dx into delta x. So that is going to be equal to dy by dx. 20 pi, just write it. Delta x is what? It's k by 10. Write it here, k by 10. This get cancelled. You have 2 pi k. So this is 2k pi or 2 pi k centimeter square. So the approximate change in the area of the plate when the increment in the radius is k% is 2k pi or 2 pi k centimeters. Find the percentage error in calculating the surface area of a cubical box if an error of 1% is made in measuring the length of edges of the cube. So we have a cube. Cube is a 3D shape in which all the edges are of equal length. So there is some error in calculating the surface area, okay, if there is a 1% error in computing the length of the edge. So whatever is length, 1% was the error. So what is the error in surface area? We'll use the concept of errors and approximation of differentials. So please assume the surface area of, and you know it, surface area of a cube is 6x square. If you assume the edge is x, the surface area is 6x square. But we are not using the actual value. We are trying to find out x, because y, or you can say the surface area is 6x square. You can call it as surface area is directly proportional to x square, which is the edge square. This is the actual value, you already know that. But we are talking about y is directly proportional to x square. Proportionality is important because that will comprehend the changes. So y is surface area, what is x is the edge we are assuming, and y is equal to x square. Y is directly proportional to x square. There is a 1% error. What is the side we have taken? X. So delta x by x into 100 is given as 1% is equal to 1, right? So here we have to say dx is equal to delta x and dy is equal to delta y. That we already know. So in order to find out delta x, let it be like that. In place of dy by dx, we have to differentiate. X square is 2x. So delta y will be what? Dy by dx into delta x. So dy by dx is already 2x with us. Delta y is dy by dx is 2x. What is delta x from here? This goes up, this goes down. X by 100 from here. So x by 100. Dy by dx, we have taken 2x. And this one, delta x we have taken from this one, 100. X by 100. So delta y is 2x square by 100. What is y? Y is already x square. As I told you, it's directly proportional, but you can call it as x square. So 2y by 100. So delta y, now you can bring this y down because you have to find out the percentage error in y. So it is 2 by 100. Delta y by y, as there's a change, percentage error in delta x. Similarly, the percentage change in y is delta y by y into 100. So you can just bring this 100 here. You multiply both sides by 100. You will, on the left hand side, you will get the percentage error in calculation of surface area, which is delta y by y into 100. On the right you will get 2. So the final thing is the percentage error in calculating the surface area is 2 in this case. Alright, when the error in computing the edge is 1%. Okay, this question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.